morning, everybody, one more time.
Morning.
My name is Professor Cihan Çobanoğlu, as I told you before. I am the conference chair here. Thank you, first of all, for coming to Vietnam, especially if you're not from Vietnam, which I believe that many of you are not. This is the 17th conference that ANI is organizing, and we always, as a tradition, do a research academy one day before the conference starts. Our conference normally starts tomorrow, but we wanted to offer this to you. I would like to introduce you our speaker today in the morning. In the afternoon, Dr. Faizan Ali will also have a session. Dr. Mostafa is a senior lecturer, Rasoolimanesh.
Yes, Rasoolimanesh.
Rasoolimanesh is a senior lecturer at the Faculty of Hospitality, Food and Leisure Management, Taylor's University in Malaysia. He has published many articles. Actually, his bio said several articles, but many articles. I always tease him that he goes to bed and in the morning 2 papers.
So you know that 7 was on the day he was writing the bio. That day was 7.
That day was 7, yeah.
So just kidding.
He's very highly productive, very high quality researcher in high impact SSCI journals such as Tourism Management, Journal of Travel Research, Journal of Sustainable Tourism, International Journal of Contemporary Hospitality Management, Cities, Habitat International, International Journal of Tourism Research, among others. Most of his published papers utilize PLS-SEM method, which is what we are going to do here, using WarpPLS and SmartPLS software packages. Dr. Mostafa has recently collaborated with a number of well-known scholars in PLS, such as Prof. Ned Koch, developer of WarpPLS software, Professor Christian Ringo, developer of SmartPLS software, Professor Marco Schatzstedt, Professor Jose Roldan, and their work has been published in top-tier journals. In addition, Dr. Mostafa has conducted several workshops on PLS-SEM. I also would like to add that Dr. Mostafa is one of the co-chairs for this conference and all the other ANI conferences that we have been doing. He's been instrumental in our paper review process, scientific paper review process. He himself manages that operation there. Also, he is the special issue editor for Journal of Hospitality Tourism Technology, which I am the editor of, and he already produced a very high quality with Dr. Faizan Ali here, a very good quality special issue, PLS-SEM, on this topic, which, by the way, it's early site, it's been cited already. The minute that it was online, it's cited. Also, I would like to introduce Dr. Ali, Faizan Ali. He's going to do in the afternoon the session. He received his PhD in marketing from the International Business School, University Technology, Malaysia in June 2015. Dr. Ali holds an undergraduate degree in Business Administration and Information Technology with distinction from Institute of Management Sciences, University of Peshawar, Pakistan, and a master's in management with a dissertation on consumer behavior in airline industry from Glasgow University, UK. Dr. Ali's research interests are in areas of customer experience, service performance, quality, customer satisfaction, and behavior. Dr. Ali is also enthusiastic about developing new scales and working on various methodological aspects of hospitality and tourism research. He has authored more than 70 international reference journal articles and international conference papers. His research has been accepted and published in top-tier journals, just like Dr. Mostafa here, and received many research-based awards. Dr. Ali is an active member of academic hospitality associations. Currently, he serves as the coordinating editor for the International Journal of Hospitality Management, assistant editor of methodology for International Journal of Contemporary Hospitality Management, and also Journal of Hospitality and Tourism Technology, again the journal that I edit. Dr. Ali is an associate editor for the Journal of Global Business Insights, which is published by ANI. It's an open access journal. Doesn't cost any money to submit or read the articles. He also serves on editorial boards of various other journals. Dr. Ali is a trained expert in usage of various statistical tools, such as structural equation modeling and partial least squares, as he is going to also do this workshop in the afternoon. And Dr. Ali is an assistant professor currently at my institution, so I'm proud to call him as a colleague. at the University of South Florida, Sarasota Humanity, which is in Florida.
Thank you.
And so I would like to also welcome all of you to this workshop, and I turn the floor to Dr. Mostafa. Dr. Mostafa.
Thank you very much. Thank you very much, Dr. Shihan, for nice introduction. As Dr. Shihan mentioned, I'm Mostafa. You can call me Mostafa. I'm going to conduct this two sessions about basic and fundamental of PLS-SEM, and also in next session we'll talk about moderator and mediator and how we can deal with moderator and mediator in PLS-SEM context.
Can we have a picture before starting?
Okay, of course.
Yep.
After we finish, also one picture.
Everyone sees me? Faizan, you need to come.
I will go with it.
Mostafa, please come too.
No. Oh, you shouldn't. I was taking.
Okay.
1, 2, one more.
Muhyiddin, don't take my belly.
It's too late.
Okay. Before starting, I would like to thank Dr. Shihan for providing this opportunity for me to talk about PLS. Actually, I love PLS, and so it's a very good opportunity and a nice time to talk about PLS-SEM. And also would like to thank Dr. Faizan as the chair of Research Academy to provide this opportunity, and it's time for talking about PLS. Okay, before starting PLS, just I want to show you something. As Prof. Chihan mentioned, I used PLS, different software, WarpPLS, SmartPLS, and Odonco in my different papers, and collaborated with the developer of this software like Netcoke. Netcoke is developer of WarpPLS, and also the Christian Ringley is developer of SmartPLS software. We have some paper and collaborated in some project. We have
Just quickly one announcement, I'm sorry. Guys, these are the keys for two softwares which Dr. Mostafa is going to explain. SmartPLS and WarpPLS, right? The SmartPLS is 2 months free license, Warp is 4 months.
3 months.
3 months, sorry. One request, please do not share these keys with your friends and colleagues, because this is specifically for people who are in this room attending the academy, and a limited number of licenses. So if you share it with other people, some of your friends cannot use it here. Okay, so just use it for today.
Yeah.
Okay? I mean, you can use it for a few months, but do it today here. Don't
To
share
the
it
people
out.
that are participating in this workshop.
Okay?
Okay.
All right, thank you.
As Dr. Chihan mentioned, recently we edited a special issue for Journal of Hospitality and Tourism Technology about PLS in tourism and hospitality. We received a lot of papers for this special issue, and 13 of these papers have been accepted, and 10 of these papers are already online. You can see here 10 of these papers, and 3 of them will be online very soon. And addition to one editorial that I wrote with Dr. Faizan. And this editorial, I think, is interesting editorial because we focus on measurement and structural model assessment based on recent development in PLS. Also, we work on recently published another book, Applying Partial Least Squares in Tourism and Hospitality Research, with Dr. Faizan and Prof. Chihan. And this book is ready for pre-order. You can pre-order this book in Emerald Bookstore or also Amazon. This book will be available on December. in this book, very famous and good people have some chapter like Prof. Ned Cook and Prof. Hensler and some others, and different topics of PLS-SEM we discuss in this book. So we can, you can, if you are interested, you can use this book. Okay. Let's start with some basic issue in structural equation modeling and partial least square structural equation modeling, or PLS-SEM. How many of you before used the PLS? Okay. And how many of you are familiar with PLS?
Familiar.
Okay, heard about PLS.
Yeah.
Okay. Okay. So I try to start from the from some basic point in PLS, and we want to use two software and want to demonstrate two software, SmartPLS and WarpPLS to you, and how we can use for PLS analysis, and how we can interpret the result. Hope in this limited time, two sessions, we can handle this software and just at least go through the software and perform some basic analysis. In this two sessions, first I will try to talk about some basic things in structural equation modeling, some criteria for assessment of measurement model and structural model. And next session, what's the mediator and moderator, and how we can do mediator and moderator assessment in PLS context. The first thing is structural equation modeling, called second generation of data analysis. Most of us work with the first generation of analysis, but in first generation of analysis, we have some limitation that second generation or structural equation modeling can deal with this limitation of first generation. Two main characteristics of SEM or second generation of analysis is the first one, SEM can handle a very complex model with different independent and different number of independent and dependent variables. You know, in first generation, just we can, once we can perform analysis based on one dependent variable, right? But SEM doesn't have this limitation and can handle a framework with different layers and different number of the dependent variables. Okay. So, for example, if you have some independent variable and various number of dependent variable and different layers, okay? Right? A very complex model like this with the 3 dependent variable and 2 layer. So this can be handled in SEM. And the SEM doesn't have the limitation of first generation of analysis that we need to work just with one dependent variable. Okay, so the framework and the model can be handled simultaneously and all model together, right? So this is the first reason and first the main characteristic of structural equation modeling. The second one, structural equation modeling can work with latent variables. Especially in social science, most of variable and construct that we are working are latent variable. What does it mean? For example, you want to measure satisfaction, okay? You want to measure beliefs, you want to measure intention, okay? Feeling. You cannot measure satisfaction, intention, beliefs based on one observed item. Okay? When you want to measure a price or household income, for example, so these items are observed items, and you can measure directly this item. You can measure directly household income. Okay? But when you want to measure satisfaction, it's not possible to measure satisfaction or feeling by some number. So to deal with this type of construct, you define some items, and based on these items, 1, 2, 3, 4, 5, based on these items, you measure satisfaction. Right? This type of construct that we can't measure directly, and we measure based on some observed items, this construct and this variable called latent variable. Okay? And can measure indirectly. So this is second main reason to use SEM and second characteristic of SEM. So SEM can work with latent variable. For example, if you have satisfaction in your framework, you want to measure satisfaction, and you are using first generation. How you measure satisfaction? Based on these 5 items, you get the average of these 5 items and use this average for satisfaction in your framework, for example, to perform multiple regression. Right? So you consider all these items as the same item. The items with same weight, same effect on creating satisfaction, and get the average and measure satisfaction. But in SEM, we can use this item. We can use these items and directly create your framework and perform analysis. So this is the second characteristic of SEM that we prefer to use structural equation modeling when we work with the complex model with different layers and different dependent variables, and also when we are working with latent variable or latent construct. Right? Okay. Some concept in when we are working with the SEM, we need to know some concept. Okay. The first thing is exogenous and endogenous construct. Exo or endo construct. We use this word instead of independent variable and dependent variable in the context of SEM. Okay, why? For example here, this framework, this variable here in this layer, we can call this variable dependent variable or independent variable. We cannot call, because in SEM we have different layers and different interrelationship between constructs, right? So we use different words for construct, name of construct. We use exogenous and endogenous construct. Okay? We call this layer the construct that hasn't appointed any arrow to them. So these three constructs don't have any arrow that appointed to them. These constructs called exogenous construct. Okay? But if we have some construct, some latent variable that some arrow appointed to this construct, these called endogenous construct. Exogenous construct or exoconstruct are similar to independent variable, and endo is similar to dependent variable, but not exactly. Because here, this is endo, but can be independent for this variable. Okay? Or moderate, or mediator. Okay. So, the first concept that we need to know in context of SEM is the name of construct, endogenous and exogenous. The second thing is inner model and outer model. When we say inner model refers to the relationship between constructs. The relationship between constructs. Okay, look at this framework. This relationship and this relationship that are based between constructs. Between constructs called inner model or structural model. So inner model or structural model refer to relationship between constructs, between latent variables, right? But when we talk inside the construct, within a construct, and refer to relationship between observed item, the items that we measure, and latent variable of construct, this part, this relationship called outer model or measurement model. So here, for example, in this simple framework, this part and this part and this part, okay, relationship between these items. These items are observed items. Observed items are questioning your questioner. Okay, very simply, your questioner. For example, you measure based on Likert scale. Right? So, this called measurement model or outer model. This one and this one. But this relationship called structural model or inner model. Okay. So, for when you develop a framework, you need two types of theory. You need a theory to support, a theory or theories to support a structural model, means relationship between construct, and also you need some theories to support measurement model. Why these items can measure this construct. Okay, so when you develop your questionnaire, you should look at the measurement theory for each construct. Why these items can measure this construct. So, outer model or measurement model refer to this relationship and need measurement theory, and a structural model or inner model refer to this relationship between construct and need structural theory to develop your frame. So this is a second important concept that when we are dealing with and we are using SEM, we need to know. Okay, this is another example. Here, this relationship and this relationship is part of measurement model or outer model, and this one, and this relationship is a structural model or inner model. Okay. Look at the different. We have three constructs here. Okay. Look at these three constructs. You can see any differences between these three constructs are involved in this framework, in this model. The direction of arrow. Okay. Here, the direction of arrow are from item to construct, to latent variable to construct. But here, the direction of arrow is from construct to items. So these two show two types of measurement model. Two different types of measurement model. So when we develop our questionnaire and when we develop our framework, we need to know our construct. The direction of arrow should be from item to construct or construct to item. We apply different criteria to assess. You don't have chair. We need to apply different criteria to assess this type of measurement model. So we need to be very careful about these two types of measurement model. Later I will tell you, actually we have three types. Okay, we have three types, not two types. Okay. Okay, this is the secret behind the directional arrows. Okay. In the literature, we have at least two types of construct. Say at least because in recent literature, another type of construct now is under development, and some researchers discuss another type of construct. Okay, later I will show you what is it, this recent type of construct. Okay, so but first we focus on these two common type of construct. These two types are reflective and formative. Okay, when the directional arrow directional arrow is from construct to, for example, this one is x, x1, x2, and x3. When the directional arrow is from latent variable or construct to observed variable, we call this type of construct as a reflective construct. reflective construct. Reflective construct means each item, each observed item reflects the meaning, whole meaning of construct. So each item can represent the construct, can represent latent variable. So this is the meaning of, simple meaning of reflective construct. Okay? So, for reflective construct, x1, so each observed variable, observed item represent x, so represents the whole meaning of construct plus an error. Plus and error. So, and this lambda here called outer loading. Outer loading. Lambda 2 square of lambda represents the variance of x explained by x. So, in reflective construct, each item can represent the meaning of construct. So, for reflective construct, we say each item has two parts. One is common variance. Common variance is the variance of latent variable. The variance of latent variable, this common variance is identical for all observed items. And another part is uncommon variance. This another part is error. And this one is different for different observed items. So, for reflective construct, if we remove one item, what will happen? Still we have another items that these items can represent the meaning of construct. So this is the main characteristic of reflective construct. Okay? Okay.
Excuse me?
Yes.
What about factor loading?
This is factor loading.
Oh.
Lambda.
This is lambda is factor loading or outer loading.
Outer loading.
Okay? In PLS or SEM, we call this one outer loading for reflective construct. But outer loading is similar equals to factor loading, right? But what about formative one? Formative construct, you can see the directional arrows. Directional arrows come from observed item to latent variable or to construct. It means the observed item, the multiple regression of item, observed item create latent variable. So, each item provides some part of variance of latent variable. Okay? When we perform multiple regression, okay, for multiple regression, We have x1, x2, and x3 on x. Let's assume this is a multiple regression. Okay, in multiple regression, when we have three independent variables, we say these three independent variables create the part of variance of dependent variable. So based on that, we define R square. We calculate R square. So we say R square is explained variance of x by independent variables. The share of variance of x that is explained by independent variables. So this is the meaning of multiple regression. Okay? So we have same here. When we say this construct is formative construct, means x1, x2, and x3 together create or form latent variable. So we call this type of construct formative construct. Right? And each item, like multiple regression, each item represents some part of this construct. Okay. One question. If this is the definition of formative construct, what happens if we remove one item?
Okay.
We cannot predict the construct effectively.
Right. We cannot establish this construct. Or, in other words, if you remove one item, it means we lose some part of meaning of latent variable or construct. So in formative construct, we cannot remove the item easily.
Okay.
Right? But in reflective, we can. Because in reflective, each item is supposed to represent the meaning of construct. But in formative, no. In formative, we have different definition. Okay? So, okay, later when I show you the software and explain how you can remove that one. Okay, later I will discuss this issue. Okay? Okay, for example, this one. You are from, most of you from hospitality and tourism. Okay? We want to measure satisfaction, guest satisfaction, about some specific hotel. Right? So, and want to examine relationship between satisfaction and some other item. Some satisfaction and loyalty, satisfaction and revisit, and some antecedent for satisfaction. Right? This relationship, satisfaction with loyalty, refer to a structural model. Which theory we use to hypothesize, which theory we use to conceptualize relationship between satisfaction and loyalty. This is related to a structural model. But what about measurement model? How you measure satisfaction? Which question or which items you use to measure satisfaction? Okay, this is one type of question that we use in our questionnaire. Okay, I feel well in this hotel. First question. Second question, I'm always happy to stay in this hotel. And third one, I recommend this hotel to my friend, for example. The meaning of each item can represent the meaning of satisfaction. And these items are high correlated. What does it mean? Okay, if I feel well in this hotel, so it means I'm always happy to stay here. So there is high correlation between these two items. And if I remove, for example, this one, still these two can represent the meaning of satisfaction. Okay, but what about this question? This question, the first question you ask about service in this hotel, service quality, right? The second one you ask about personnel. The third one you ask about room equipment. Maybe you can add some more question. Ask about accessibility. This hotel is accessible and is easy to access. Another one is environment. You like the environment of this hotel? Okay, what happened when I use this type of questions? Is it possible that I satisfy with service, but not satisfy with personnel?
Yeah.
Maybe the personnel of the hotel are not friendly, but the service is very high quality service. So, and the environment is not nice and attractive, but the service is very high. So, when we ask this type of question, it means I measure satisfaction by formative items, not reflective. When I use formative items, I can't easily remove one item. Right? For example, if I remove this item, so I can't measure satisfaction about service. And just based on this question, measure satisfaction about personnel, room equipment, environment, and some other questions. So, for formative construct, it's not easy to remove one item. And if we remove one item, it means we lose some part of meaning of satisfaction. This is the formula or equation for formative construct. Okay, I told you the meaning of construct, right? The variance of construct is represented by multiple regression of items, W1x1, W2x2, and W3xt, plus error. Plus error. What's this error part? This error part is some part of meaning of satisfaction that we don't include in here. We don't include related items here. Okay. If you measure satisfaction, for example, based on these three items, it means you don't include satisfaction about environment and accessibility and maybe some other items that you don't know. Right? So, when you measure satisfaction, these three items just can create some part of meaning of satisfaction. But some part of meaning of satisfaction still is missing. This missing part is error term here. Okay, so when we develop a formative construct, when we develop a formative construct, we need to consider, I will be back again to this point. We have one important stage, one important step for validation of formative construct. This step is external validity or redundancy analysis, to make sure that we include most of items that measure satisfaction. Okay, later I will explain how we need to do this external validity. But this one is because of this error term. We need to make sure that this error term is less than 50% of variance of formative construct. At least this item can establish 50% of meaning of construct. So for this one, we need to run external validity or redundancy analysis. So when you develop a questionnaire and your items are formative items for some construct, you need to add some reflective items for that construct, or one overall item to measure external, to assess external validity. To assess external validity for formative construct. Okay. This is a second common type of construct. But this one is another type of construct that recently the literature, especially the literature of PLS, discuss about this. This is composite, but in previous literature, some papers discuss two types of formative construct: causal formative and composite formative construct. Causal formative construct is a common type of formative construct that the items cause or establish construct, latent variable. But composite construct is a bit different. Composite construct in some literature recently was developed, and in composite construct, the main difference with the causal formative construct is in composite construct we don't have error term. It means when you know these items, these three items can establish this construct, the total meaning of this construct, the complete meaning of this construct, and we have no error term, so this type of construct can be called composite. We don't have any specific meaning for socio-economic characteristics. Based on your research, you can add some item to create socio-economic characteristics. Maybe in some study you add education, household income, and in another study you add age also. Right? To create what? To create socio-economic construct. When you create this construct based on these three items, based on household income, based on age and education, you know this construct called artifact construct. So you create by yourself. The meaning doesn't exist in real world. Satisfaction, the meaning, regardless of your measurement, you measure reflectively or formatively. The meaning of satisfaction, the concept of satisfaction exists in real world. So you try to find some measurement method that this is a step called operationalization, right? You find some items to measure satisfaction, reflective or formative. But some constructs don't exist in real world. Socioeconomic characteristic, you create this one based on some specific item. So you know there is not any error, any missing item here. This type of construct called composite construct. This is one type of construct. For example, you want to measure performance in one specific company, and you know you create a specific scale to measure performance. You want to measure performance based on 1, 2, 3, 4, these 5 items. Okay, so you create performance scale for this company based on these 5 items. So this construct is composite construct because you don't have any missing part. Right? This is one type of composite construct. Another type that I think is very, very, very important, and I believe there are a lot of mistakes for this one, is second order construct. Okay? Higher order construct. For example, you want to measure, you want to assess sustainability. Sustainability is part of your framework. You want to assess the effect of some variable on sustainability and effect of sustainability on other variables. Okay? You measure sustainability based on 4 dimensions. Economic, based on some items, social, environmental, and governance. Right? And based on these 4 dimensions, you create sustainability. Is there any other dimension for sustainability? Is there? No. Because sustainability, we know, sustainability includes 4 specific dimensions. So when we create sustainability, we have no missing part or error or term. So most of time, second order construct, most of time, but we have different types of higher order and second order. But most of time, second order are reflective composite or formative composite construct. So these can be different, another type of composite construct. Why I emphasize on this? Because when we have composite construct, we need to apply different criteria to assess composite construct. Even with formative construct, there are different criteria to assess composite construct. Right? Okay. So this is a decision tree by Hensler for reflective and formative and composite construct. Is the construct is nature of construct is latent variable. It means exists in real world. Okay, so if the construct is consequence of item, it means the direction of arrow is from item to construct. So this is sorry. Yeah. relational indicators. If the indicators are, if the indicators are antecedent, this is formative. And if the indicators are consequence of latent variable, is the meaning of reflective, right? But if the construct is artifact, we create the construct. Don't exist in real world. Okay, this can call composite. But you can add another type of composite. Another type of composite for higher order or second order construct. Because in this type of construct, still we don't have error. I will give you the PowerPoint. Yeah, so no need to take a photo. Yeah, but you need. I'm not sure. You need to provide your email address, and later we can send you the PowerPoint.
When to decide whether to use the formative or effective in the framework? Is it based on the theories?
It's based on the measurement theory that you have and the nature of your construct, right? But actually the part of decision is based on researcher, okay? For some construct like satisfaction, you can decide. You can decide to use formative or reflective construct because you have specific items for reflective construct, reflective measurement, and some other items for formative measurement. But you need to be careful and you need to know, okay, your items are formative or reflective. You need to be aware of this one. But for some construct, you have no choice. When you look at the nature of the items and the literature measurement story, you can see the nature of items are from different perspectives. And the items are not correlated, or not supposed to be correlated. Right? So, in this case, okay, you need to understand the item is, the construct is reflective or formative. Okay. Here I provided some points that this is from our editorial. Our editorial for a special issue that I mentioned for Journal of Hospitality and Tourism Technology, we focus on these three assessment of these three types of measurement model: reflective, formative, and composite. How we can assess these three types of constructs, and also a structural model. And you can find, I think, good point for spatially measurement model and the comparison with. There are some mistakes. Later I will talk a bit about this mistake. So we try to highlight this mistake. Okay. Okay. Reflective measurement model. Each indicator includes a common variance from the construct and error term, which is supposed to be uncorrelated. The error term is supposed to be uncorrelated because it's not part of common variance. We have a common mistake in covariance-based SEM. When we cannot get a good result, we try to correlate error term to get good result. We modify the framework and model to get good result. And after that, we are very happy. Oh, we get good goodness of fit. Okay? But the error term are supposed to be uncorrelated. How we can correlate to get better result. Okay. For second one, the measurement or formative construct is in construct level and represents the missing part of formative construct. Okay, the missing indicators. One point that here I want to add. For when we develop a reflective construct, so if we find some good questionnaire and good previous study, we can adopt the items for reflective construct. But what about formative construct? Formative construct, we need to do a very comprehensive literature review to find the items as much as we can. Because more items help us to reduce missing part and reduce error term. So for formative construct, we need to go through the literature and do a very comprehensive literature review to find related items for this formative construct. And for composite. Composite are not cause and effect, like reflective and formative. But composite, the items are ingredients of construct. You make this food. You make this composite construct. So the items that you put are ingredient of this construct. And there is not any cause and effect relation between items and construct. So we have no error term. Also, the indicator of a composite can represent a conceptual unity for construct, especially for second order construct. Second order construct is different story, right? In second order construct, the items can be can have cause and effect, cause relationship. These 3 dimension, these 4 dimension can make a composite construct without any error, but the items are not just ingredient of construct. Represents the meaning for whole construct. So we have a conceptual unity for items. Okay. And very brief explanation about 2 types of SEM. Actually, we have 2 different types of structural equation modeling. Covariance-based SEM and PLS, or variance-based SEM. PLS is common type of variance-based structural equation modeling. So we have 2 types, covariance-based structural equation modeling and variance-based structural equation modeling. These 2 have some main differences, and we need to know about the differences between these 2 types of SEM. Covariance-based SEM was developed by Groskok, and PLS-SEM by Wold and Groskok together in 1980 to 1980 decade. But when they developed these 2 types of SEM, they look at these 2 types of SEM as a complementary method, not competitive method. Now, if you look at the recent literature, some scholars try to attack to PLS, okay? But from the covariance-based SEM perspective. But the developer believe these 2 methods are complementary, and we can use these 2 methods in 2 different contexts based on 2 different requirements. Cannot be used for same situation. So we need to know which context, which framework, and which model, which study PLS is suitable, or variance-based SEM is suitable for this study, and for which study we need to use covariance-based SEM. Okay? Okay. Variance-based SEM, or PLS, because of the algorithm that we use to calculate the score of construct, and to estimate the parameters, to estimate the outer loading, to estimate the outer weight, okay, and give other parameters in our model. PLS, because of this algorithm called composite-based SEM. But covariance-based SEM called factor-based SEM or common factor-based SEM. This is different with the meaning of composite construct. Recently, this is a common mistake, and somebody messed these two different contexts. When we talk about composite-based algorithm and composite-based SEM, they think we must use just composite construct, but it's not correct. PLS can be used for 3 different types of construct: for reflective, for formative, and for composite construct, and combination of them. But covariance-based SEM just can be used by for reflective and formative construct if your framework include just reflective, so it means all of your construct, all of your latent variable are reflective, or all are formative. There is some method like Mimic to deal with combination of reflective and formative, but there are a lot of critics for this combination, for covariance-based SEM. So, based on the algorithm that they use, covariance-based SEM called common factor SEM, and PLS called composite-based SEM, but it's different with composite, reflective, and formative types of constructs. PLS, the algorithm that the PLS used, try to maximize the variance of latent variable, endogenous construct, or dependent variable. So, PLS, the algorithm, try to maximize, focus on maximizing the variance, explained variance of endogenous construct. But covariance-based SEM try to minimize and focus on minimizing the discrepancy between model parameters from model, covariance matrix from your framework, your model, and covariance matrix from your data. So, in covariance-based SEM, these two covariance matrix from your from estimated parameters of your framework, and covariance from your data compare, and try to minimize the differences between these two covariance matrices. So, for covariance-based SEM, we need goodness of fit. Goodness of fit represent these differences between covariance matrix from data and covariance matrix from your model, and try to minimize. So the focus of covariance-based SEM is on GOF, goodness of fit. So the first things that when you are performing covariance-based SEM, the first things that we report is, okay, what about goodness of fit? If goodness of fit is acceptable, so you can go to other criteria. and you try to modify your framework to improve goodness of fit. Because actually the covariance-based SEM, goodness of fit represents the differences between these two matrices. Okay? So, when we develop a new framework, when we want to develop a theory, we are looking for maximizing the endogenous, the explained variance of endogenous construct. When we develop a theory, when we combine some theory and develop a new framework. So, for theory development, we need to use PLS. But what about covariance-based SEM? Covariance-based SEM we use for theory testing. Okay? You see here, the most important thing is minimizing the difference between model and your data. So when you have an established theory, established framework, and new data, and you want to see these data set can fit in this framework, can fit in this model, yes, you need to use covariance-based SEM. Because the aim, the objective, and the mission of covariance-based SEM is minimizing the difference between data and framework, data and model. So it's used for theory testing. You want to test a theory, a framework in new context. But when you develop a new theory, when you develop a new framework, you add some new variable in previous framework. So, in this case, you want to maximize the explained variance for dependent or endogenous construct or variable. So, in this case, you must use PLS. When you want to justify using PLS-SEM or covariance-based SEM for your study and your paper, this can be one of main reasons to justify. Don't go for small sample size and non-normal data to justify using PLS.
Yeah.
The main reason, one of the main reasons to justify using PLS is dealing with theory development. The first thing. Second thing, PLS can work with the combination of different types of construct. Reflective, formative, composite. So when you have a complex model, including different types of construct, you must use PLS. Covariance-based SEM cannot work in this context.
Previously we used MOS, is it?
MOS is one software to perform covariance-based SEM. For covariance-based SEM, we have different software like MOS, M+, EQS, and different software. Okay?
So covariance is
Yeah, covariance-based SEM is in MOS context.
previously people use when they are doing PhD, they use MOS software, and then they try to get the PhD, but PhD is supposed to be
You can see,
right?
yeah. You can see a lot of published work in high quality and top tier journals, and I'm sure most of them conceptualize new framework and new theory, because for top tier journal you need the significant contribution, significant theoretical contribution. So most of them try to combine different theories, try to develop new theory, but use MOS. Okay? But based on the literature, the concept of covariance-based SEM is for theory testing, not for theory development. Covariance-based SEM is not able to develop new theory. Okay? And another thing, for prediction, PLS-SEM is prediction-oriented approach. When your study is focused on prediction, PLS is a must. There is some limitation in covariance-based SEM because actually in covariance-based SEM, the common algorithm is maximum likelihood algorithm, and when we use maximum likelihood, and in the context of covariance-based SEM, we focus on covariance between items. Okay. Covariance-based SEM is not able to calculate specific score of construct. So when covariance-based SEM cannot calculate the specific score of latent variable or construct, so it's not able to use for prediction. So when your study is prediction-oriented, you want to predict something, PLS is a must. You cannot use covariance-based SEM. So this can justify using PLS. Theory development, prediction, and complex framework and model, including different types of construct. But if your study meet this requirement, okay, PLS also can work with smaller sample size compared to covariance-based SEM, but not very sample. Some rule of thumb like 10 times rule that before we use in the literature, that you maybe you can find this rule, that 10 times of highest number of construct or formative construct no longer valid rule of thumb for sample size. This is the end of this paper. This table is very useful table, and I think one of the best guidelines so far for different part of when you apply PLS, from sample size until assessment of measurement model, structural model, mediator and moderator. We try to put criteria for assessment of these different steps in this table. So it's a very good guideline for when you apply PLS. The first one is sample size. Okay, Koch and Hadaya in their recent work presented two methods, inverse square root and gamma exponential method, for calculating minimum sample size for PLS. These two methods are very valid methods to calculate minimum sample size, And another one is if you don't have access and you cannot calculate these two, WarpPLS software automatically can calculate the minimum sample size based on these two methods. I will show you later. But if you don't have access, you cannot calculate these two methods, you can use G-power, and based on power analysis, you calculate minimum sample size. Okay. So, but again, previous rule of thumb, like 10 times rule, is not valid based on recent literature.
Is it minimum 30 respondents?
No. Based on if want to, there's not any magic value based on your. It's based on your framework. But the work of Reinertz, the 2009, this he calculated different sample based on number of construct and number of items, and he proposed 100 sample size, the minimum sample size can work in different contexts with PLS. But it's better to justify and to calculate based on power analysis, or if you want based on these two methods.
Can we use the G-power?
Yes, G-power.
As a guideline, the number of respondents that we want to collect.
Yes. To calculate minimum sample size, you can use G-power, and based on power analysis, calculate minimum sample size.
So, for example, the G-power will come up with 350. So we collect, for example, 400. Is it?
Yeah, it's okay. Because the G-power give you minimum sample size. So this is minimum. So it's more than this is okay. Okay, this is some software for covariance-based SEM, and MOS, Israel, M+, QS software for. And for variance-based SEM or PLS, we have also different softwares like SmartPLS, WarpPLS, Adanko, and you can see a lot of software that you can use. The common software most of researcher uses SmartPLS and also WarpPLS. I try to show you these two software and how we can create a framework and how we can do a basic analysis with these two software, SmartPLS and WarpPLS. WarpPLS, because of some abilities to calculate nonlinear, called Nonlinear SEM software. Okay. We have still 30 minutes, right? Okay. Another step is assessment of measurement model and structure model. Okay, we create our framework and we know about measurement framework, measurement model or outer model, and also inner model and structure. Now, we collected our data. Now we want to assess our framework, measurement model and structural model. Okay, so as already I mentioned, a framework has two parts: measurement model part or outer model and structural model. In assessment, we need to assess these two different parts. We need to assess measurement model, measurement part or outer model, and also structural. There are some criteria to assess measurement model and structural model, but based on the type of measurement model. They have three types of measurement model, right? Reflective, formative, and composite. For reflective measurement model, we need to assess reliability and validity. For reflective construct, for reflective measurement model, we need to assess reliability and validity. Two types of reliability should be assessed, should be checked. Indicator reliability and construct reliability, or internal consistency. For indicator reliability, the outer loading or factor loading should be higher than 0.7. Should be higher than 0.7 to represent at least 50% of variance of latent variable, variance of construct. Okay? This is reflective construct. Lambda 1, lambda 2, lambda 3. Okay? Lambda 1, 2. Okay? Should be at least 0.5. That represent at least 50% of variance of latent variable. So if we assume this variance 50% or 0.5, lambda should be 0.77. So we say lambda should be higher than 0.7 to represent at least 50% of variance of latent variable by constant, by item, by reflective item. But before we discussed that other variables also other observed items supposed to represent the meaning, whole meaning of this construct. Okay, so the loading between 0.5 and 0.7 also is acceptable if we can meet these two criteria. These criteria meet the thresholds. So, in first step, loading should be higher than 0.7, but between 0.5 and 0.7 is acceptable if these criteria meet their threshold. Okay. But lower than 0.5, we should remove in when we face with this loading, low loading. So for first one, indicator reliability, loading should be higher than at least 0.5, but between 0.5 and 0.7 we need to check these criteria. Okay, for internal consistency or construct reliability, we can check, and we need to check different criteria: composite reliability, Kernbach alpha, and rho A. Rho A is recent developed criterion for assessment of internal consistency. Kernbach alpha is old one. Composite reliability is a criterion that most of literature suggested when we work with PLS, when we apply PLS. So it's better to report at least these two for internal consistency or construct reliability: composite reliability and rho A. If also Kernbach alpha is suitable, you can report 3 of them. These criteria for assess internal consistency should be higher than 0.7. So composite reliability, Kernbach alpha, and rho A should be higher than 0.7. Generally, Kernbach alpha has lowest value, composite reliability highest one, and rho A is something between these two. So maybe you can't get suitable Corenbach alpha. And but rho A and composite reliability higher than 0.7, so you can report this. Right? So for internal consistency and or construct reliability, you need to check these criteria for reflective construct. This is for reliability. For validity, we need to check two steps for validity: convergent validity and discriminant validity. Convergent validity, using convergent validity, we check that these items can converge to establish reflective construct or latent variable or not. For this one, we assess average variance extracted. Average of variance that explained by these items. And these average variance should be higher than 0.5. Here I explained that square of lambda should be higher than 0.5 to get lambda higher than 0.7. But if the average of these three variants is higher than 0.5, so and one of the items is lower than this, so it's acceptable, and we can go ahead to keep this item. So for convergent validity, we check average variance extraction or AVE and should be higher than 0.5. And the last one is discriminant validity. Discriminant validity, we check the difference between constructs involved in your framework. And the construct involved in your framework should be enough divergent. So it means the construct should not represent same or similar concept. So we check discriminant validity to make sure you involve different construct in your framework. And the constructs are different enough. Right? So we check discriminant validity for this divergence. There are different criteria for assessment of discriminant validity. Cross-loading is one of the first criteria was developed for assessment of discriminant validity, but no longer suitable criterion to assess discriminant validity. But these two, Forna-Larker criterion and HTMT, are suitable criteria to assess discriminant validity. But what is Forna-Larker and HTMT? HTMT is the operation for heterotrait monotrait ratio. Okay. Forna-Larker criterion, if we have, for example, A, B, C, okay, A, B, C, AVE of each construct, AVE of each construct, average variance extracted, should be higher than a squared correlation of this construct with other construct. So if we have here square correlation with between A and B, and here A and C. This should be higher than these correlation. This should happen for all involved construct in offering. So we check AVE with correlation. And the AVE of each construct should be higher than squared correlation. Or a square root of AVE, it's the same meaning. A square root of AVE higher than correlation between each construct and other construct. So check square root of AVE with correlation or AVE with squared correlation. This is formula darker criteria. Another criterion is HTMT. This criterion was developed for PLS. For PLS and discriminant validity assessment was developed in 2015 by Hensler and Ringle and their colleagues. And in their study, based on a simulation study, they showed HTMT also can work well with PLS context. They calculate HTMT based on a bit complex equation and formula. But the value of HTMT, should be lower than, but also still there is some way to keep. If the outer weights are non-significant, but the loading are significant, you remember for formative construct we cannot easily remove item. If we remove item, it means we lost the meaning of, some part of meaning of construct. Okay? So, oh.
This is yours?
No, okay. Wait, sorry. This is mine.
That's yours?
Yeah.
That's cool.
Yes.
No.
Does anybody have a plug for this is
Okay.
English? You can use this one.
No, also, yeah.
Okay. Be careful if you pass here.
I think no.
Does anybody have a plug? Like an adapter? This is UK.
Yeah, it's
You can't
Malaysia.
do-
Malaysia
Okay.
based.
Long enough.
Sorry.
Wow.
Maybe we can put it in the middle.
This is okay, thank you. Okay. Yeah. Thank you
You
very
haven't?
much.
Maybe that's easier that way. Sorry.
Okay.
Technology.
2030.
I know, 2030, yeah. You need power. One day it will be wireless electric. Maybe 10, 20 years later we will not need this plug, but not now. Not now.
Thank you very much. Okay. So if the outer weights are not significant, you can check the significance of outer loading. The significance of outer loading. If the outer loading is significant, still you can keep your item, the item of formative construct. So now let's look at the outer loading. Okay. Significance of outer loading. Also for this study and this data set, outer loading are not significant. So it means there is something wrong for this construct. and the data we collected. Okay, so not it's supposed to be formative, right? But we cannot get significant weight or loading. So we need to reconsider this construct and see how we develop this construct.
What about changing it back to reflective and see if it works?
And we already tried, and for reflective, we see we don't have acceptable loading. Okay, so there is a problem maybe in developing this construct or data collection. Okay, but in a good situation that we have. We develop our formative construct and collect data, the weight should be significant, or at least the loading should be significant. And if the outer loading are significant, we can keep the formative construct. So for formative construct, we need to check VIF and loading. If loading are not significant, check the VIF and weight. If the weight are not significant, we check the outer load. Okay.
No, the VIF is below than 5, right?
VIF, yes. Yes.
So we cannot keep it still because of this outer weight and loading.
I'm sure there is some problem here and should not be like this. But if the loading also is not significant, it means there is some issue that you need to look at. What's the issue that you get this result? Okay. So this is assessment of measurement model in SmartPLS. Reflective and formative measurement.
Question is, how about items that is positive, negative question? Do we need to correct the direction first before we start?
Yes. If you have, if your questions are in different directions, some questions are positive questions and some questions are negative, you need to correct it before analysis. But actually, it's better your questioner you put and you ask the question in same direction. Okay, because different direction maybe confuse the respondent. But if you use, okay, you need to reverse your data before analysis. Okay. Okay, this is assessment of measurement model. Next step is assessment of structural model. Right? I want to create another framework based on this data set, based on other data we have. We have another dimension, another construct here. 3 more construct in this framework. We collected data is community attachment, involvement, and economic gain, if I'm not mistaken. Okay, community attachment, okay, environmental attitude and economic gain. Environmental attitude and economic gain. Also, I think we have involvement here. Yes, involvement. Okay, so I want to create new framework, remove these 2, and see effect of community attachment, environmental attitude, and economic gain on support for tourism. Support for tourism. Just remove this one, delete this problematic construct. Okay, and add 3 more constructs. Okay. Okay, use this one. Okay, click on community attachment and transfer community attachment. The second one is environmental attitude and economic gain. Okay. Okay. We have 3 more construct. You see, when I add these 3 new construct, the color changed from blue to red because we don't have linkage between these 3. Okay, change the name, rename, community attachment. This one and this one economic, right? And connect these 3 to positive perception. Okay, and also connect to SOP. Okay. So, okay, now I don't want to talk about mediation. I added some variable to this framework. Keep positive perception. Positive perception effect on support for tourism development. But for positive perception, based on theory, we have some antecedent. Community attachment, environmental attitude, and economic gain. That these 3 effect on positive perception and support for tourism development. Okay? We can justify based on the theory. But to make a simpler framework, let me remove a relation between these 3 and support. No. Later we can add. Okay. Okay. Now we have a new framework including 5 reflective constructs. In first step, we need to run PLS algorithm and check reliability and validity, convergent validity, and let me do again for this one. Okay. So check the loading. Okay. The loading are okay, all except this one. You can see the loading here is lower than 5, 0.5, and negative. So we should remove this one. Just this one. And okay. Now the reliability, indicator reliability for all items are okay. Higher than 0.5. Okay, check the construct reliability. One good things for SmartPLS is working with color. Okay, when you click on construct reliability and you see all are green, it means are all okay. Higher than 0.7. If one of them is lower than 0.7, you can see here red one. So green one means you establish construct reliability for all these 3 criteria. Okay, and then discriminant validity. Discriminant validity for this is for the darker criterion, you need to check this one, square root of AB with correlation. Correlation, it's okay. Correlation and correlation. This one higher than all correlation. And for HTMT, all green. So you mean HTMT for all construct are lower than 0.85. Green means lower than 0.85. But still lower than 0.9 is acceptable. But here is all are lower than 0.85. So we established measurement, assessment, and reliability and validity for these 5 reflective constructs. Okay, now for next step we need to check structural model. We need to check structural model. Okay, let me go to okay. For a structural model, some of these criteria for assessment of a structural model is very common, and all literature, previous literature, focus and mention about these criteria. Okay, but some of them are very new, and recent literature suggests to report for assessment of structural model. For example, this one is a very new one. Assess the models out of sample prediction using PLS predict. The advanced technique suggested by Shemoli, Professor Shemoli, and her colleagues, and also other scholars work on this, and recent literature suggests this assessment as a necessary part of a structural model assessment. Okay, but still you can report these 4 criteria for assessment of a structural model. Still, all journals are not requested for this assessment, but I think soon will be. Okay, but these 4 is the main criteria to assess a structural model. For assessment of a structural model, you need to report R square for endogenous construct. You need to check size, significance, and sign of path coefficient. Significance and sign of path coefficient. I didn't mention sign, but sign is very important. I'll explain later. Effect size, and for prediction relevancy, at least you need to report QS score. But as mentioned, recent literature suggests to report PLS predictive criteria. Okay, so we need to report at least these 4. Okay, R square. You are familiar with R square. Okay, but there are different thresholds for R square in different area of research. For example, this is the threshold suggested by Chin, but it's in marketing context. So he suggested 0.67 is can be considered high, 0.33 moderate, and between these 2, and higher than 0.19 small, but lower than 0.19 is not acceptable based on Chin. But Cohen suggests another threshold. Okay, Cohen say higher than 0.02 It's acceptable. And 0.2 here is in this category, weak. And lower than 0.2 is not acceptable. But based on Cohen in behavioral science, 0.2 can be considered high. Why? Actually, R square is based on the independent variable that you include in your framework. R square is explained variance by these independent variables. Okay? If, for example, your framework is success factor of performance, and you include all success factors of performance, so you expect to get high R square. But if you add some variable, or you assess the satisfaction or intention to revisit, do something, right? But just you want to assess the effect of these three variables on intention. But it doesn't mean these variables are all variables that affect on intention. So the R square should be low, because the R square is just explain variance by these involved constraints. So the threshold for R square depend on your area, and you need to look at the previous study and see what they got in previous study. Okay, so this is for R square. For path coefficient, okay, of course, the path coefficient should be significant. The path coefficient should be significant. And also for hypothesis testing, this is part of your structural model assessment. You need to get significant path coefficient to support your hypothesis. So the second criteria to assess a structural model is significance of path coefficient. Significance of path coefficient is based on size. Okay, so the size of path coefficient is high, so you can get significant result. If it's low, you cannot get it. Right? Another thing is very important in path coefficient assessment is sign of path coefficient. What does it mean? For example, you hypothesize effect of A on B and say, okay, A has positive effect on B. But in your analysis, you get negative result. The path coefficient is negative. Right? Still you get significant result. But this significant result is not acceptable. You cannot support your hypothesis because you hypothesize positive relationship, but you get negative. So because of that, the sign of path coefficient also is very important. So you need to check size, significance, and sign of path coefficient. Okay? And another thing is effect size. Effect size show effects. Okay, R square is explained variance by these three. Right? Effect size is the share of explained variance by each one. The share of explained variance by each independent variable. For example, if you get R square 0.3 by these three constructs, so it means that the explained variance by these three is 30% on variance of dependent variable. But effect size is share of each contribution of each independent variable on this R square. So effect size also is very important to compare the contribution of these different independent variables. And the last one is Q square. Right. The last one is Q square, and the value of Q square, the Q square show the predictive capability of your framework, but it's the in-sample assessment. Show the predictive capability, and Q square should be just higher than 0. Higher than 0 is acceptable. So we need to apply at least these 4 criteria for assessment of a structure. Okay. Now go back to result of okay. This is our framework. Oh, why didn't? Okay. This is our framework. So we check measurement model. We assess measurement. 1 point. Before going to a structural model, you need to make sure acceptability of measurement model. So assessment of measurement model is first step. Without assessment of measurement model, you cannot go forward for structural model. Okay? So now we check measurement model, and we want to assess structural model. So we need to check R square, path coefficient, significance of path coefficient, effect size, and Q square. Okay? One by one. We have a PLS algorithm here. R square. Okay. R square for these two, positive perception and support, 0.35 and 0.14. So it's acceptable in this area. So just can report and discuss what the previous study said, and is acceptable in our context or not. For path coefficient, you have the size and sign of path coefficient here. Okay? And also you have path coefficient in this spot. If you click on path coefficient, you can see the effect of community attachment, economic gain, and environmental attitude on positive perception. Right? These three. And effect of positive perception on support. So, okay, you can see the just size and sign of path coefficient here. But still you don't know these path coefficients are significant or not. For significance level of path coefficient, you need to check bootstrapping result. Okay? And the effect size also you can check here. F square here means effect size. So if you click on effect size, okay, you have just two green and one black and one red. Okay. For effect size, if the value of effect size is lower than 0.02, 0.02, even if you get significant path coefficient, okay, if you get significant path coefficient, but the value of effect size is lower than 0.02, your hypothesis cannot be supported. Lower than 0.02 is not acceptable effect size. Between 0.02 and 0.13 is small. Between these two, 0.13 and 0.35 is moderate, and higher than 0.35 is high. Okay, again back to here. Okay, this one is red, means lower than 0.02. This one is 0.024. It's acceptable, but it's very small. But for these two, 0.4 and 0.17 is moderate and high for effect size. So you can interpret the result of effect size based on these values. Okay, now let me run again bootstrapping and see basic and see significance of path coefficient, because one of the important step for structural model is path coefficient. Okay. Here you can okay, click on path coefficient. This is the path coefficient. Community attachment on community attachment on positive perception, economic gain on positive perception, environmental attitude on positive perception, and positive perception on support. So you have 4 path coefficient here. You have 4 paths, and this is the path coefficient. 0.16, 0.53, minus 0.02, and 0.382. This is path coefficient. But in this system, we want significance level of path coefficient. Okay? Here is t-value and p-value. Based on p-value, 3 of them are significant. The p-value should be lower than 0.05. Right? P-value 0.05.
First one is 0.09, right?
Right, yeah. 0. Yeah. So it's not acceptable.
So only 2.
Just 2. These 2. And also you can interpret based on t-value. Okay. For t-value, here you have 0.09. Please listen carefully this point. Okay. Here 0.09. But the t-value is 1.65. We have 2 types of hypothesis. One tail and 2 tails. One tail means you hypothesize the relationship in positive or negative way, in directional way. Your hypotheses are directional. You say A has positive effect on B. A has negative effect on B. 2 tail means your hypothesis doesn't have direction. A has significant effect on B. For one tail hypothesis, if we get t-value higher than 1.64, it means this relationship and this hypothesis is significant. Here we got t-value 1.65, but the p-value is 0.09. It means p-value is calculated based on 2-tail hypothesis. But our hypothesis is 1 tail. So we need to divide this one to 2. So this one will be 0.098 divided to 2 is 0.0454. right? Okay, yeah, 0.49. So it's lower than 0.05. So we can accept this hypothesis and support this hypothesis. So one tail and two tail is also important when you hypothesize relationship and check the result of significance level. Also here you can check confidence interval. Okay? Confidence interval. And for if you use confidence interval, if zero is not within, doesn't fall in lower level and upper level, so you can accept and support hypothesis. For confidence, using confidence interval, bias corrected or confidence interval. So there are different level of different technique and approach to assess significance level of estimated parameters in PLS. Okay. So for a structural model, we assess R square, sign, size, and significance of path coefficient, F square, and the last one is Q square. For Q square, we need to run another analysis. Q square is calculated based on blindfolding resampling. Blindfolding resampling. This one. So we need to run blindfolding. So click on blindfolding and go with the default omission stance and click on start. Okay. So here you can see the Q square. The Q square for both positive perception and support is higher than 0. So are accepted. So this is criteria for assessment of measurement model and assessment of structural model in PLS. Okay.
Just now about the one tail or two tail, the hypothesis. Is it everything must be in one tail or two tail, or we can change the hypothesis direction?
It's based on the theory that you use.
Oh.
You need to support the direction and hypothesis based on theory. Okay, but when you submit your paper to a journal, reviewers, not always, but often like one tail hypothesis, because they say you need to know, okay, this effect is positive effect or negative effect. So if you hypothesize in positive way or negative ways, it means you hypothesize one thing. Okay. But maybe in some study, actually based on also theory, you don't know, and just you know and expect some relationship and some effect. So you can hypothesize.
Basically, the result will be based on two tail. So we have to divide.
No, here also we can get one tail result. Okay. Okay. When you want to bootstrapping, perform bootstrapping, here you have one option: one tail or two tail. If you click on one tail, p-value will be one tail. Okay. Okay. Now p-value is 0.04. Right? So based on SmartPLS, you can assess measurement model and structure.
What about the p-value of 1.96?
1.96
96.
p-value.
P-value.
96 is for two tail.
Two tail.
Okay. if your hypothesis is two-tailed, okay, t should be higher than 0.196 to get p-value lower than 0.05 and significant result. For one tail, if you get t-value higher than 0.196, your p-value will be 0.01, more significant result. Okay? For one tail. Okay, this is a SmartPLS. I also want to show you WarpPLS. And but WarpPLS we can do faster because we know the basic of assessment of measurement model and structure. But I want to show you how we can create a framework in WarpPLS and how we can see the result of exactly this result in WarpPLS. Why I want to show you WarpPLS? Because actually each software has some advantages and some capability in some specific area. For example, WarpPLS actually has very good feature for nonlinear relationship and nonlinear assessment. And also for mediator and moderator, I believe WarpPLS is more powerful than SmartPLS. But for example, SmartPLS now, based on the new feature of SmartPLS, is more powerful for multi-group analysis. So if you know different software, based on your study, you can pick suitable software and use suitable software and get a suitable result based on the objective of your study and your frame. Okay, so I want to show you how we create a framework in WarpPLS. If you install WarpPLS in your computer, you can use the key that he gave you. This key is 3 months free license. Okay, when you click on WarpPLS 6, the latest version of WarpPLS is WarpPLS 6. Okay, and you go to this window and just, if you don't have if you have want to enter new license, you need to enter new license here, new key here, and proceed to use the software. Okay, this is still we have time.
Yeah, about 12:30, we're going to have a break.
12:30?
7 minutes. Right?
No, it's not right. No,
What time did we say?
but this is last session. We don't have any session after this.
Oh, okay.
I think because I don't have time to go through the moderator and mediator.
So normally,
Yeah, I think
12:45.
12:40, but we start at 11. I think we can go to at least 2. If you agree, we go to 1.
1 p.m.
1 p.m.
If everybody agrees, no problem. We don't have any problem. It's up to you. You have the energy.
Yeah, I have energy. Okay, thank you. Okay, this is WarpPLS software. Okay, and just create a simple framework in this software and show you how we can analyze, and try to show you mediator and moderator very briefly in these two software. Okay, so create same framework for this one, WarpPLS. When you go to WarpPLS environment, okay, you have 5 simple steps. You need to follow these 5 simple steps to create your framework and see the result of your analysis. WarpPLS, you don't need to perform analysis 2 times or 3 times to get path coefficient, to get significance of estimated parameters and Q score. one time you can get all together when you follow these 5 steps. Okay, so okay, this is the first step. Click on first step. If you already have WarpPLS file, you can call from here. If you don't have, you can create new project. New project file. Create project file. So click on project file. Okay? And show you the folder that you want to save your file. Okay? Let me go to... Okay. Research Academy. Okay. I select this one to save my file and result. Glow search. Okay. First step done. Okay. The second step, click on second step, and in second step you need to read your data set. In a SmartPLS, just we can read CSV file. But in WarpPLS, we can use CSV, tab delimited file, comma delimited file, and Excel file. We can use all of these types of file. Okay? So, read from file. Click on this one. Okay. And here, if you click on all file, I have 2 files here, exercise. One is Excel file and one is comma delimited file or CSV file. I can use both these files. Okay? So, click on one. Okay.
So don't need to put in spaces, just from Excel.
Yeah, just from Excel. And also for SmartPLS, you don't need to put in SPSS. Just we need to get CSV. CSV also you can get from Excel. Okay. So just click on next and finish. So now you can see your data set here and check for some mistake, errors, and if you have some problem, you can check here. Okay? Does the data look correct? So if it's correct, you can click on yes. So this is the second step in WarpPLS. Second step. The third step is some pre-processed data. In this step, check for missing value and some problem in your data set and try to solve this problem. If you have some missing value, use different technique to solve your missing value. Okay? So just click on this one and see and at the end, standardize your data and show standardized data, and you check your standardized data. Okay? And click on OK. Okay. This is your data that converted to standardized data. Right? So if it's okay, you can go for... So you already have done 3 steps. Read your data and do some pre-processed data analysis and go to step 4. Step 4, you create your framework. In step 4, you create your framework. So click OK. This is the white window that WarpPLS gives you to create your framework before analysis. In our framework, we have 3 antecedent, positive perception, and support for tourism development. So we have 5 reflective constraints. Okay. For each one, latent variable option. You click on latent variable option, create latent variable, click. Okay. First one, community attachment. The first variable is, the first construct is community attachment. You select from this indicator list and transfer here. Just click on add. Add 1, 2, 3, 4, 5, 6, 7. Transfer indicators items of community attachment to this box. Here you can select reflective or formative type of your construct. If your construct is reflective, okay, so you can go, save and go to next one. And if it's formative, here you need to change to formative. Okay, so save. This is the first one. The second one is environmental attitude. 1, 2, 3. Save. Economic gain. 1, 2, 3.
So cannot shift.
No. SmartPLS is more user friendly,
That's right.
but WarpPLS is more powerful in some cases. So you need to decide which one is better for your study. Okay. And next one is positive perception. 1, 2, 3, 4, 5. And the last one is soft. Okay. One, 2, 3, 4, 5, 6. Okay. 6. So you have 6 construct here. Okay, and now you need to create direct link between these variables. One of the advantages of WarpPLS use different algorithm for outer model. So you can now without link also you can perform analysis. So it's suitable when you want to assess, when you want to do scale development or validation of questionnaire. Because when you want to validate your questionnaire or one scale, you don't consider and you don't know relationship between construct. Just you know each construct and the associated items. So using WarpPLS, now you can run the analysis and give you the result of measurement model assessment. Okay? But I link to create whole model. Direct link 1, 2, 3, and 4. So now we create these 3 affect influence on positive perception, influence on positive perception, influence on support for tourism development. So, okay, when you complete your framework, just here save and close. Okay, save and close. First, save and close. Okay. And the last step is performing analysis. Now you already created your framework, and proceed to step 5. Perform SEM analysis. Just click. Now you have all results here. When you click on SEM analysis, so perform SEM, WarpPLS perform all analysis, including estimate the parameters and calculate the significance level of all parameters and give you all together. For example, here you can see path coefficient with p-value. P-value is significance of this path coefficient. P-value and also path coefficient, p-value and this. R square and R square. So you have all result together here, okay? But if you want to see the result in in table, okay, this is the part that you can see the result. You can see different results here. Okay? Okay. Our framework includes the 5 reflective constructs. So, first step, we need to check loading. Right? Loading. Indicator loading and cross-loading. Indicator loading and cross-loading. But WarpPLS provides several loading. The best one is for basic PLS analysis, the first one. First one. Click on first one. Okay. Oh, you can see the loading here and cross-loading with other construct. The loading here, the loading here. So, the loading for community attachment is inside the bracket. 0.74, 0.81, 81, 74, 72, 71, 43. Just this one is lower than 5. You can remove this one. And for others, also this one, EA3. Remember for SmartPLS also we had problem with EA3. So we remove this one. And this one okay, this one okay. And for support, also for support, all are higher than 0.5. So this is the step for assessment of indicator reliability. You check indicator reliability based on this step. Next step for measurement model is construct reliability, and for reliability is construct reliability. You need to check composite reliability, Cronbach alpha, and rho A. Okay? Okay. Okay, view. This part, you have a lot of information in this part. View latent variable coefficients. Okay? If you click on this one, here you can see composite reliability and Cronbach alpha. Rho A, you need to check another things to find rho A. But these two are available here. So for 5 construct, all Cronbach alpha and composite reliability are higher than 0.7. AVE is higher than 0.5. So here you can check AVE, convergent validity also, and construct reliability. Here also you can check R square and Q square for a structural model. So you can get R square here. This is R square for positive perception and support, and this one is adjusted R square. And Q square. Also Q square is higher than 0. So here you can check also Q square. So in this table you can fulfill construct reliability, convergent validity, and some criteria for structural model, R square and Q square. One interesting things, okay, for normality, most of recent literature, previous literature, when we check for criteria for PLS, some of the literature mentioned for PLS no need to check normality because PLS can deal with non-normal data. But the recent literature say still you need to check normality, and this, if your data is non-normal, this non-normal data and multivariate non-normal cannot be very high. Okay? Here, so for SmartPLS, we don't have multivariate normality for construct or normality for each construct. But here provide also normality for WarpPLS provide normality for construct. So you can see different criteria for assess the normality, and you can also see the histogram. Okay, this is the histogram for community attachment. Community attachment, and this one is for environmental attitude. So you can see the histogram here and different criteria. One of them is skewness and cortices. You can see the result of skewness and cortices here for these 5 constructs, not for item, for construct. And also provide for item, but construct is much more important. Okay? And so you can here check the normality of your construct. Okay. So for assessment of measurement model, we pass indicator reliability, construct reliability, and convergent validity. Still, we need to check discriminant validity. Okay. For discriminant validity in WarpPLS, you need to check this part. Correlation among latent variables. So before we checked this one, and now check this part. Okay. View correlation among latent variable and square root of AVE. Square root of AVE. So, okay, in this table, you can see square root of AVE within the bracket and the correlation here. Correlation between community attachment and all other 4 construct. Here is inside the bracket is square root of AVE of environmental attitude, and other are correlation. So you can see this should be higher than this correlation. So it's okay. This one is okay. This one is okay. This one is 0.77 higher than correlation, and this one also higher than correlation. So you can pass for Landarker criteria. WarpPLS so far doesn't calculate HTMT. Okay, maybe in future version or next version, the developer add HTMT to this one. But so far, just you have for Landarker criterion for discriminant validity assessment and cross-loading, but cross-loading is not valid criterion. Okay. So this is the last step of measurement model assessment using WarpPLS. But for a structural model, we check R square, we check Q square, but still 2 criteria should be checked: path coefficient, sign size and significance of path coefficient, and effect size. Okay? In view part, you can click on path coefficient and p-value. But here, all the information you need Okay. This is the path coefficient and p-value. This one is not significant, these two. These two are not significant, but these two are significant. Okay? And the next is standard errors and effect size. This is effect size. This one is higher than 0.02, 0.01, 0.33. This one is moderate. This one is still moderate. Not acceptable and small. So you can check and report effect size also. Okay. Why? Sometimes we need to use WarpPLS. Okay. This is your framework. But you don't know something behind this. Okay? Okay. In WarpPLS, in setting part, we have many interesting things here. You can play with WarpPLS and check these different algorithms for outer model and inner model. For example, here, okay, there is a lot of different outer model algorithms. In a SmartPLS, just we have PLS mode A and PLS mode B. Like here, and PLS-C for performing analysis close to factor-based analysis, when our framework involved just reflective question. Okay? But here you have a lot of outer model algorithms. This is first things. And the second things is, okay, inner model. You can select different inner model or a structural model algorithm. Linear, WarpPLS is Euler algorithm, and WarpPLS is S-curve algorithm. For example, when your dependent variable is dichotomous variable. Dependent variable is a variable, just single item variable, just with two levels, yes and no. Dependent variable. So your dependent variable is dichotomous variable. PLS software and also SmartPLS cannot perform analysis for dichotomous dependent variable. Because when we have dichotomous dependent variable, we used to always we use logistic regression. Because logistic regression follow S-curve relationship between IV and D. In WarpPLS, using WarpPLS tree, we can create S-curve algorithm. So using Warp tree, we can use PLS for dichotomous dependent variable. Okay. Okay. Another thing, I just want to change and see. Okay. If we assume the relationship is linear, and again perform analysis. Okay, this is the result. R squared is 0.33 and R squared is 0.12. I keep this one and change the setting to Warp 3, for example, or Warp 2. And again perform. Okay. Okay, you can see the R square here is 0.63 and this one is 0.18. R square here is 0.33 and this one is 0.12. You can see significant improvement for R square. This is a non-linear relationship and this one is linear. Okay? And you can see the graph for this one. For example, for this one, we select non-linear, linear. Yes, linear. Okay. Okay. This is your data set. And this is the line that describes this relationship. Okay? For economic gain and the positive perception. And now look at the non-linear one. Okay. So when you apply nonlinear, because for nonlinear, try to find best fit curve for this data set. When apply best curve instead of line, you can get higher and improved R square and path coefficient. So this is one important capability of WarpPLS. Recently, we published one paper in Journal of Destination Marketing and Management, just based on this relationship. We try to check resident perception of tourism development. The effect is linear or non-linear. Okay, and this is the finding of this relationship. And you find the pattern is non-linear pattern. But all previous studies assume linear relationship. So this can help to interpret in different way. Interpret the result and of course some practical implication based on this result. Okay. So this is for WARP and SmartPLS assessment of measurement model and structure. Okay. Okay. We have no time to go through moderator and mediator. Okay? But just want to show you how we can see the result of mediator assessment in WarpPLS and also SmartPLS. Based on the result that we already got for assessment of the structural model. For assessment of mediator, there is a very long discussion and story, and still many of people use Boron and Kenny, but Boron and Kenny approach is not acceptable approach, no longer valid approach, and somebody called dead approach. So Hayes and Preacher in their recent works and study book and a lot of paper and other scholars confirm that the best way to assess mediator is assessment of indirect effect using bootstrapping. or resampling method, not Baron and K. So for assessment of mediator, you need to check significance of indirect effect. Okay? For example, here you have, okay, you want to check as mediation role of positive perception between these tree and support. So you have 3 indirect effects, right? 3 indirect effects. So you need to check significance of these indirect effects. For using WarpPLS, here WarpPLS provide the indirect and total effect. So you can click on indirect effect and see, okay. For example here, this is indirect effect for community attachment and support, environmental attitude and support, and economic gain and support. And the mediator is positive perception. So this is indirect effect, and here you can see the p-value for indirect effect. P-value for indirect effect. For indirect effect, just this one, the p-value is lower than 0.05. For another 2, indirect effect are not significant. So here you can see just positive perception mediate relationship between economic gain and support, but doesn't have mediation role for other 2. This indirect effect also you can check in SmartPLS. For example, this is a result of a SmartPLS. Dr. Chihan is the last word. Okay. In result of WarpPLS, also you have a specific indirect effect here. When you click on a specific indirect effect, this is result of bootstrapping. Okay, you can see okay. This is community attachment, positive perception and support, economic gain, positive perception and support, and environmental attitude, positive perception and support. This is at indirect effect, and this is t-value and p-value. Okay? For this one also, just this relationship is significant. This indirect effect is significant. So, just positive perception can mediate relationship between economic gain and support, and cannot mediate relationship between other 2 independent variables. So you can see the result of indirect effect in both SmartPLS and WarpPLS. Thank you for your patience.